Dear students, today we'll take up a little of chemistry, that is about carbon. Now comes the question, what is carbon? As you know, carbon is an element. What kind of element is carbon? Carbon is a non-metal and it is a solid non-metal. That's also another point. Carbon is a solid non-metal. Then comes the question, what is its atomic mass? Its atomic mass is 12. It means it has got 6 protons and 6 neutrons in its nucleus, and it has got 6 electrons distributed over two orbits. K shell has got 2 electrons, and in the next shell you have got 4 electrons, and thereby I can say that it is a tetravalent element. It has got 4 elements there, it was 4 electrons, and it is a tetravalent element. And it has got 4 valence electrons, and therefore it belongs to 14th group of the periodic table. It belongs to 14th group of the periodic table. So much about this carbon there. Now here I have just written this one here. You can just see that one. Am I right? Carbon, that is a non-metal. Its atomic mass is 12 and its atomic number is 6. Because it has got 6 protons, its atomic number is 6. It has got 6 protons and 6 neutrons in the nucleus, and because it has got 6 electrons have been distributed over 2 orbits. In the first orbit it has got 2 electrons, in the next orbit it has got 4 electrons. Therefore it has got 4 valence electrons. These 4 valence electrons will determine the period. It belongs to 14th group. It belongs to 14th group of the periodic table, not period. It belongs to 14th group of the periodic table. And then its valency is 4. Its valency is 4, therefore it is called a tetravalent element. Amele, we will just see what are the use of this one. Now, I'll just come to allotropic forms of carbon. Now comes the question. So, what is allotropy? You already studied in the previous classes. Allotropy. Allotropy is the property of an element by virtue of which an element exists in more than one form with the different physical properties but the same chemical properties. Again I repeat, allotropy is that property by virtue of which an element exists in more than one form with the different physical properties but more or less the same chemical properties, again I will say. Because white phosphorus reacts with sodium hydroxide. Red phosphorus does not react with sodium hydroxide. I can't say that they have got the same chemical properties. So more or less chemical properties will be the same. So once again, for the last time, I am repeating the definition of allotropy. Allotropy is that property by virtue of which an element exists in more than one form with different physical properties but more or less the same chemical properties. Then coming to the allotropic modifications of carbon. A carbon exhibits a number of allotropic forms. All these allotropic forms are broadly classified under 2 groups. One is crystalline form of carbon and another is non-crystalline form of carbon. Non-crystalline form of carbon is also called amorphous carbon. Amorphous is a Latin term meaning no form. Amorphous means no form. So, see crystalline form of carbon and non-crystalline form of carbon. Under crystalline forms of carbon, we have got 2. What are the 2 one? Diamond and graphite. Diamond and graphite are the crystalline forms of carbon. Whereas under non-crystalline forms, I have got 6 there I have written. What are the things there? Number 1 is wood charcoal. The second one you can write animal charcoal. The third one you can call it as coal. And then we get coke and then lamp black and the last one is the gas carbon. They are the 6 different modifications under non-crystalline forms of carbon, that is amorphous carbon. So they are the 6 different forms. Again, wood charcoal, animal charcoal, coal, coke, lampblack, and the last one is gas carbon. They are the different forms of non-crystalline forms of carbon. But regarding crystalline forms of carbon, you got only 2. One is diamond and that is graphite. Now we should just go through certain details with respect to each variety of the allotropic forms of carbon. The first one is a diamond. What are the things that we have to just know about diamond? Diamond is the hardest substance ever known. It is the hardest substance ever known. That's the first one. And the second one is its refractive index is 2.5. Its refractive index is 2.5. And its density is 3.5 grams per cc, or specific gravity is 3.5. And then coming to the other one, ignition temperature. The temperature at which it catches fire. That is, its ignition temperature is 900 degrees centigrade or Celsius. At 900 degrees Celsius, it catches fire and burns. And that is the ignition temperature of diamond. And diamond is unaffected by chemicals. That is very important. For this purpose only, diamond is so precious. You must know that one. Colorless diamond is so precious. Why? Because it is unaffected by chemicals. Chemicals have no action upon this one, and therefore it is used in jewelry. And then the next one is it is a bad conductor of heat and electricity. Diamond is a bad conductor of heat and electricity. So what are the things that we have understood? It is the hardest substance ever known. That is the first property. Second one is refractive index is 2.5. I will talk something about that one. I have already talked to you in physics about brilliance, and there its refractive index is 2.5, and its density is 3.5 grams per cc, or its specific gravity is 3.5, and its ignition temperature is how much? 900 degrees Celsius, and the next one is it is a bad conductor of heat and electricity. They are the important properties of what you call diamond. Okay, sir. Coming to other aspects of diamond. There are 2 types of diamond. Diamonds, that is, one is black diamond and there is, which one? Colorless diamond. I don't call it as white diamond, it is called colorless diamond. Now, about black diamond is not costly at all, you must understand that. This black diamond is used in glass cutters. Gajana cutters in glass cutters, and in rock drillers we make use of this one, black diamond. Again repeat, black diamond is used in rock drillers and glass cutters. Whereas white diamond, that is colorless diamond, is precious. Why? Because it is a sparkling crystal. And you must understand that diamond, white diamond, is cut and polished in such a way that as much as total internal reflection will take place, to see that it becomes a shining crystal. And this shining crystal is called a brilliant, and that brilliant is used in ornaments. Again I repeat, white diamond by itself will not be shining unless it is cut and polished in such a way that it becomes a shining crystal. How exactly it becomes a shining crystal? As much as total internal reflection will take place, so that it becomes actually a shining crystal, and that is called a brilliant. Black diamond is also called carbonado. Black diamond is called carbonado. White diamond, that is colorless diamond, is called a brilliant there. It is used in which one? Ornaments. Another point that you have to do is, colorful diamonds are also available, but color of the diamond is on account of the metallic impurities present in the diamond. Metallic impurities present in the diamond will give that diamond that color. So, color of the diamond is on account of the metallic impurity present in the diamond. So much so about diamond to start with. Then I'll just take up graphite. Now, graphite. What is the graphite? Graphite, once again, is a Greek word. Graphite is a Greek word. It means I write. Graphite means I write because it leaves a black mark when scratched on a paper. Take a graphite piece, scratch it on a paper there. It leaves a black mark on the paper and therefore it is called graphite. Graphite means I write. And it's a grayish black smooth solid. Nodi. Diamond is the hardest substance ever known. Graphite is very smooth. It is a very smooth solid. It is actually lustrous solid, I can say that one. It is a grayish black lustrous solid, very soft in nature. And then if we just take it's the temperature at which catches fire at 700 degrees centigrade. If we just heat it, it catches fire. Actually, between 600 and 700, it catches fire and burns. Graphite catches fire and burns. And graphite is not again, it is stable towards chemical. However, concentrated nitric acid slowly reacts with graphite to form graphitic acid. But we don't take into consideration that. So it is almost stable towards chemicals. Graphite is very smooth as solid. It is unaffected by chemicals. Its specific gravity is 2.5. Its specific gravity is 2.5. Then coming to uses of graphite. As you know, the use depends upon its property. Graphite is very soft. Graphite is very soft. And therefore, it is used as a solid lubricant. It is used as a solid lubricant. Sometimes it is mixed with oil, which is used as a lubricating oil for machines also. So, that is the first one. So, that use depends upon its property that it is, let us say, it's a very soft solid. Next one, it leaves a black mark when scratched on a paper. Therefore, it is used in making pencil leads. Graphite mixed with clay. We just use it to make what you call pencil leads. That's also another property. Graphite is a good conductor of heat and electricity. It is a special property. Usually, non-metals are bad conductors of heat and electricity. Graphite is an exception. Graphite is a good conductor of heat and electricity. Therefore, graphite is used to make, first of all, electrodes. Because it is a good conductor of electricity, graphite is used as an electrode. And then, it is a good conductor of heat also. And therefore, it is used to make crucibles. It is used to make crucibles that withstand high temperatures. Graphite is used to make crucibles that withstand high temperatures. That is how ಯಾವ property may depend agate, you must understand that one. That is all about graphite. So, and we have just understood diamond and graphite. Another important thing, graphite is so soft, diamond is very hard. What is the reason for this one? They'll ask you this question in the public examination. It all depends upon its structure. In the case of diamond, all the 4 carbon atoms present in the crystal are equidistant from one another. In the diamond crystal, all the 4 carbon atoms are equidistant from each other, as a result of which the covalent bonds that are holding the carbon atoms are very strong. It is made up of a large number of such bonds, and it requires a large force to break many of these bonds, and therefore diamond is very, very, very hard. Again, for the last time repeating the same thing. In the case of diamond crystal, all the 4 carbon atoms are equidistant from one another, as a result of which the covalent bonds that are holding together, they are very strong, and the whole crystal may be considered to be made up of a large number of such bonds, and it requires a large force to break these bonds, and therefore diamond is very, very hard. On the other hand, when you just take graphite, now graphite, in the case of graphite, of the 4 carbon atoms or 3 of the 4 carbon atoms are equidistant from one another. Please understand, of the 4 carbon atoms, 3 carbon atoms are equidistant from one another, and the other carbon atom is not equidistant from the other 3 carbon atoms, as a result of which lattice formation will be there, layer formation will be there, and you find that lattice formation is there, and it is easy to break these lattices. So layers, and it is easy to break these lattices, and therefore graphite is very soft. Once again, I am repeating, in the case of graphite crystal, of the 4 carbon atoms, 3 carbon atoms are equidistant from one another, while the other carbon atom is not equidistant from the other 3 carbon atoms, as a result of which lattice formation is there, and it is easy to break these lattices, and therefore diamond is very soft, on account of which it is a good conductor of heat, on account of which it is a good conductor of electricity also. So structure differs from graphite to diamond, and therefore it is so. It is so much about diamond and graphite. And coming to the non-crystal forms of carbon, not much details. Wood charcoal, you know that one. So wood charcoal, how exactly you can just make, you know that one. And animal charcoal, animals actually, bones extracted from animals, actually they are heated out of contact with air in the furnace to see that or to get animal charcoal. And of course animal charcoal is used in sugar industry to remove the color there. And then coke is a very important one. That is, a coal is we should take up, I think you know that one of the fossil fuels. Coal is a very important allotropic form. And then when coal is destructively distilled, that is when coal is heated out of contact with air, you get a number of products, and 3 products actually you get, coal tar, coal gas, and coke. And coke is one of the byproducts formed when coal is heated out of contact with air, and coke is a very useful one, that is, it is used as a reducing agent in metallurgy. And lamp black, I think you know that one, that is used in ink industry. And then gas carbon is also used as electrode. Gas carbon, don't be in the form, don't be under the impression gas carbon in the gaseous form, it will be in the solid form only, and gaseous carbon will be deposited and it is used as an electrode. So there is so much about the various allotropic forms and their uses. We shall just take up the remaining things tomorrow. Thank you.